All right, let me see if we can work through a few examples of this and get the basic idea so we can be able to find these volumes. We want to find the volume of the solid generated by rotating about the x-axis. We're going to rotate about the x-axis, the region bounded by these pieces. So we're going to be the region bounded by the graph of the function, the square root of sine of x, from 0 to pi in the x-axis. So there's 0, let's see, there's pi, there's 1, and within the limits of my picture, you could graph this to get a much better picture of it, but that's roughly speaking the region we're talking about. The square root of sine is the top curve, x equals 0, x equals pi, and the x-axis. And if you rotate that about, rotating about the x-axis, that would look like this. And so it's sort of like a medicine tablet or some sort. And so we're going to find the volume. Well, the volume is given by, if I take one of these little, think of taking one of these little rectangles and taking out of here one of these little discs. Take out of there one of those discs. All right. The question is, what is the radius? That's always the question, what is the radius? Well, in this case, the radius of this red curve is the distance from the x-axis to the top. That actually is the function value. So in this particular case, and whenever you revolve about the axis, the radius is simply the function value. So we want our volume pi. The endpoints of the partition are the endpoints of the region, which is from 0 to pi. And now we need the radius, which is the function squared, pi times the radius squared, and then the last piece we need is the thickness, delta x. So it's our value is pi, the volume is pi times the integral from 0 to pi of square root of sine of x. That's just the function squared. It's always the function squared dx. It is coincidence that this pi is here. We don't need to go from 0 to pi. We could take only, if we wanted to, we could take just the left half of that if we wanted to. So we could go from 0 to pi, pi over 2, or we could go from pi over 4 to pi. We could chop this up any way we like. It's coincidence that this pi and this upper limit of integration is the same thing. Once you have the setup, the computation is straightforward. The setup is what we're after here, because this is pi times the well, first off, let's simplify that expression. Square root squared, if the function is positive, and it is just sine of x. The antiderivative of sine is negative cosine of x, and that's from 0 to pi. So we have negative cosine of pi minus negative cosine negative cosine of 0 pi times negative cosine of pi. Well, cosine of pi is negative 1. Negative 1 minus, be careful, cosine of 0 is 1, so it's minus negative 1. And that's enough negative signs to satisfy anybody, but that's 1 plus 1. So that volume works out to be 2 pi. So the setup is really what we're after now. For now, we're after the setup. I'm going to assume that once you have this setup manufactured, then you should be able to compute the integral, find the antiderivative, and compute the integral pretty well by now. So if you can set the integral up, that's really what we're after now.